So good morning students. Today we are going to start with a new topic, batteries and their types. So first of all, what is a battery? Battery is the combination of cells. Sometimes for a single cell also we use this word, but otherwise battery is combination of cells. Okay, so whether we are using a battery or a cell as a source of electrical energy, what it is? Basically, it is a galvanic cell. And you know what happens in galvanic cell? Chemical energy is converted into electrical energy. And what reaction occurs in that? Redox reaction means reduction as well as oxidation. Okay. Now for any battery to be of practical use, it must be light, it must be compact, and its voltage should not vary too much. Okay, only then it can be of practical use. Now, of how many types these batteries are? These batteries can be described in two categories. Those two categories are primary batteries and secondary batteries. So first of all, we will start with primary batteries. So why do we say primary batteries? In primary batteries, reaction occurs only once, and after use over a period of time, it becomes dead and cannot be reused again. Dead means when it will not supply any electrical energy, then we will say it is dead. Okay. Now a very common primary battery which we use is dry cell. Okay, so dry cell is the very much common battery which is used. Now the cell, let us talk about its construction. This dry cell is consisting of zinc container which will act as anode, okay, and a carbon rod which will act as cathode. This carbon rod will be surrounded by powdered manganese dioxide and carbon. Powdered manganese dioxide and carbon. It will be surrounded by this. Okay. Now the space between the electrodes is filled by a moist paste of ammonium chloride and zinc chloride. Okay. So this is the construction. In any galvanic cell, we need to know what is going to act as anode, what is going to act as cathode, and what is the electrolyte used. So these three things are to be noted for every cell. Now, how is the construction? See, this is the carbon rod which acts as cathode. Okay, and this is the zinc container, okay, in which the whole thing is packed, that acts as anode. Now this is surrounded by manganese dioxide and carbon, and there is presence of ammonium chloride and zinc chloride. Okay, so this is the paste which surrounds this. Okay, now what are the different reactions which occur in this? Anode, zinc container is anode, so oxidation process occurs at zinc. So what happens? Zinc, it gives zinc 2 positive plus 2 electrons. Similarly, this carbon rod which acts as cathode, it provides the surface for a reaction which has to occur on cathode. So what reaction occurs here? Manganese dioxide, which is surrounded around this carbon rod, that reacts with ammonium ion. From where we get ammonium ion? From the electrolyte. Electrolyte is ammonium chloride and zinc chloride paste. From that particular paste, ammonium ion comes here, and there is a release of ammonia and formation of this MnOOH, manganese oxyhydroxide. Manganese oxyhydroxide. Okay. Now, if you see what thing has undergone oxidation? Zinc container has undergone oxidation. So what does it mean? It means with the passage of time, zinc will finish. Okay, when all of zinc changes into zinc 2 positive ion, then it will end up. And what changes, what undergoes oxidation reduction? Here you can see in MnO2 the oxidation number of Mn is +4, and if you see here oxidation number of Mn is +3. So what does it mean? It means manganese has changed its oxidation state from +4 to +3, so it has undergone reduction. Okay, so this is the reaction. These are the reactions occurring at different electrodes. When we will sum up, then we will get the overall cell reaction. Okay, now this ammonia which is being produced, it combines with zinc 2 positive ion and there is formation of this complex. Okay, now this is the potential which we get out of this cell. Okay, now let us discuss one more important cell. It is also primary cell and it is called mercury cell. This cell is having use in wristwatches and all such apparatus where very small sized cell is required. There we use this cell. So it is mercury cell. Now this is the structure of this cell. Now you can see what is anode, what is cathode, and what is acting as electrolyte. So let us discuss this. Now see, in this particular cell there is zinc mercury amalgam which acts as anode. Zinc mercury amalgam means, amalgam word means when certain metal is present in the presence of mercury, then it is called its amalgam. So zinc amalgam means Zn/Hg. We will represent like this. Okay, so zinc amalgam acts as anode, and a paste of mercuric oxide and carbon, it acts as cathode. Okay, and what is electrolyte? Electrolyte is the paste of potassium hydroxide and zinc oxide. So these three things are there which are must to be remembered for any cell. So anode is zinc mercury amalgam, cathode is mercuric oxide and carbon paste, and electrolyte is paste of potassium hydroxide and zinc oxide. Okay, now what are the different reactions which occur? At anode, zinc changes to zinc oxide. Okay, now what is to be remembered here? From the electrolyte, this OH negative ion combines to form zinc oxide and H2O plus 2 electron. Now from this first reaction, what you can remember, this is cathode, so this has to undergo change. Now with what it will combine? It has to combine with this product which is formed in anode. So when this combines, it will form mercury and hydroxide ion. So how can you remember this? You have to remember that first of all, in case of anode, OH will combine with anode. Okay, and there will be formation of this. Now for writing equation for cathode, you have to remember that this has to be added with the cathode, and this will be produced as a outcome in case of cathode. So this way you can remember it. Now when we combine both the equations, then we get this type of equation. Now see, what is the difference between this particular cell reaction and previous cell reaction? The difference is, in this case there is absence of ions in reactants or products. So if there is absence of ions, then their concentration does not change. Their concentration does not change with time. Their concentration remains same throughout the life of the cell. So in this case, what is the plus point? We will get the same voltage throughout the life of the cell, but where ions are involved, there what we get, there in the beginning voltage or output will be maximum, and with the passage of time that will reduce. So what is the reason for that? The reason for that is that concentration of ions decreases with the passage of time. Okay, Now let us come to secondary batteries. Secondary batteries are those batteries which can be recharged. Okay, so if we are getting a very good secondary cell, then it can undergo charging and discharging very for so many times. Okay, if it is of not good quality, then it may function for less time, but if it is of good quality, then it may be recharged and charged again and again, and it will go on for long time. Okay, so very important battery first of all is lead storage battery. This is a secondary battery, means it is rechargeable and it can be used again and again. Okay, now let us discuss lead storage battery. Okay, now see, you can see from the picture, this is the picture of lead storage battery. Now first of all we have to see what is anode, what is cathode, and what is electrolyte. So first of all, there is presence of lead plates which act as anode, and there is presence of lead dioxide. Okay, this acts as cathode. Now see, both these things are packed in lead grids, grid of lead. Both are packed in grids of lead. One is acting as anode and the other is acting as cathode. And what is electrolyte? We take 38% solution of sulfuric acid. 38%, you know, if total volume of the solution is 100, then 38, if it is 100 ml, then 38 ml is of sulfuric acid, rest is the water. Okay, so 38% solution of sulfuric acid is used as electrolyte. Now what are the different reactions occurring in the lead storage battery? At anode, lead undergoes change. So you have to remember two things. First thing, sulfate ion is to be reacted with in anode reaction also and cathode reaction also. Okay, second thing, in case of cathode reaction, you have to remember that H positive ion is also to be added. Okay, so let us start. For anode, lead combines with sulfate ion to form lead sulfate plus 2 electrons. Similarly, lead dioxide combines with sulfate, and in addition to this it combines with H positive ion, and since it is reduction reaction, so there is also gain of electrons. So result is lead sulfate plus H2O. Okay, now when we combine these two reactions, then we get this overall reaction. Okay, now what is to be remembered? What is cathode, what is anode, what is electrolyte, and what are these reactions, and what is overall reaction? Now see, when this battery is in use, then it will undergo discharging. So that is called discharging of the battery when we are using the battery. So that time what reaction occurs? This reaction occurs. Okay, lead plus lead dioxide plus 2H2SO4, it gives 2 PbSO4 plus 2H2O. But when we reverse the connections, then what happens? Then this galvanic cell behaves as electrolytic cell. Now it behaves as see, it reverses. Reverses means this is galvanic cell. Galvanic cell means there is galvanic cell, it is acting as galvanic cell when it is discharging, and when we are recharging it, then we are reversing the connections and it is acting as electrolytic cell. Okay, so when it is acting as electrolytic cell, reverse of galvanic cell, then what happens? Then there is again reproduction of the cathode, anode, and electrolyte. So what reaction occurs? Reverse reaction occurs, means lead sulfate combines with H2O to form lead dioxide, and H2SO4. Okay, so reverse reaction occurs when we reverse the connections, and that is called recharging of the battery. Okay, now see, from the diagram you can see that there are grids. These are lead grids, and if we are packing them with lead, then they become a negative plate, and when we pack the lead grids with lead dioxide, then they become the positive plate. Okay, positive plate means they are acting as cathode, and a negative plate means they are acting as anode. Okay, so all plates are joined together, all anodes are joined together to a particular end, and all cathodes are joined together to a particular end, and those two ends are connected as a source of electrical energy. Okay, now one more type of cell is there, which is secondary cell, and it is called nicad cell, or it is called nickel cadmium cell. Okay, now what is nicad cell? It is also rechargeable, it is also secondary cell, and it is the modified form of Leclanche cell. Okay, now what is anode in this case? Anode is cadmium metal, and cathode is a compound of nickel in which its oxidation state is 3. So this substance acts as cathode. And what is electrolyte? Electrolyte is aqueous solution of potassium hydroxide. So when we take these things and use this nickel cadmium cell, its picture is shown ahead, then what is the reaction which is occurring? See, this is anode, so it will undergo oxidation. So again here what you have to remember? You have to remember that OH negative ion will combine with the anode. So cadmium plus 2 OH negative, it gives cadmium hydroxide plus 2 electrons. Similarly, nickel oxyhydroxide, this is called nickel oxyhydroxide. This combines with water, and there is addition of electron because it is reduction reaction, and there is formation of nickel hydroxide and hydroxide ions. Okay, so here what you can remember, two things you can remember. One thing, that as a product we will be getting hydroxides of nickel as well as cadmium. One thing is this. Second thing, in this for anode we have to add OH negative ion, and for cathode there will be formation of OH negative ion. So this way you can remember it. Now when we will combine both the reactions, then we will get the overall reaction. Now see, this is the nicad cell, nickel cadmium cell. Okay, so here positive plate is also there, negative plate is also there. Separator means it acts as salt bridge, okay, which helps in smooth functioning or completion of the circuit. Okay, so it is a rechargeable cell. Okay, you might have seen rechargeable cells, so this is the example of rechargeable cell. Okay, so now students, we have discussed types of batteries, primary batteries and secondary batteries, and two examples of both types. So you need to do these home assignments on the basis of whatever we have discussed. Okay, thank you.